Hello and welcome to my channel. My name is Steve Matthews and you can find me under Teeth of the Lamb on YouTube. And today is March 4th of 2022. The title of this video is The Separation of Light and Darkness. It's a sequel to another video that I put out last week, The Sun's Toroidal Field and Why a Crescent Moon has Earthshine. In that video, we went over an array of different visible aspects of what we see during a sunset and sunrise. But today, I'd like to pick one in particular that is of most interest and focus on that primarily. And that topic will be the moment at which we see sunlight receding away into the distance as it's carried away with the sun, and we pass into darkness. Today we're going to step out of the confines of the box that academia keeps us in, and we're going to look under the lid of the box and see what we see with our own eyes, and let that be our guide. So hold on. We know now that there is no curvature to the Earth due to the thousands of curvature tests that have been done, and they come back negative on the curvature. That being said, we also know that we have a sun that revolves overhead at a fairly constant range of altitudes. So the question is, what the hell are we seeing here? There is no curvature, and the sun has a very set range of altitudes. So this, my friends, will be the topic of our discussion today. That span of time that we see the barrier between light and darkness receding away toward the vanishing point. Since we know that there is no curvature, then we need to come to the next most probable and logical conclusion as to what we're seeing here. This dome of light which recedes down toward the vanishing point. After the elimination of the possibility of curvature and weighing out the other possibilities, they only come up with two. And that's either the sun is at such an angle that its light cannot shine across a flat plane, or that we're actually seeing the limits of sunlight itself and the photons. God divided the light from the darkness. Might I propose here the latter of the two possibilities, that it's light itself that has a limitation in distance and time, and the barrier that we see trailing the sun is the extent of a photon's limited life. When the sun reaches its zenith over our head, it begins its descent to our visual horizon line, and that would be the vanishing point. And trailing some 6,000 or a little bit more miles behind would be the reach of a photon, where it ceases to exist. And at sunset, and just after the sun sets out of our visual range, along comes the barrier between light and darkness, which is the reach of a photon's life, which is only a fraction of a second, but a distance of about 6,000 or a little bit more miles. And this, I believe, is what we're seeing. And we're seeing the circular pattern that it makes around the sun as light rays go out from the sun in all directions. So we're only seeing the upper reaches of that light as it's either absorbed by the atmosphere or perhaps the firmament above. Let's make a little diagram for a visual aid here, what we're talking about. So I've drawn out a flat terrestrial plane which is Earth, and the sun with about a 12,000 mile reach of light, 6,000 roughly on each side. And that as a photon is produced by the sun and released, that it travels in a matter of a fraction of a second, that 6,000 miles in any direction from the sun, and it ends its life at that point because it doesn't exist much longer than that. The largest spans of space that we have would be vertically over our flat plane, and it's doubtful that stars are 6,000 miles above the surface. So if we want to test the bounds and limits of light, we'd have to do it vertically over the surface of the Earth. And from all appearances, from what we observe and what we see, light has a definite reach. And when you consider the sun being at a high altitude above the surface of our plane, then there is nothing to physically obstruct that light from shining clear to the other side in all directions. So we would have light everywhere. It appears that light emanates from the sun in all directions. And we've seen that in some of the little video clips of sunsets with light rays, corpuscular rays coming out of the sun in all directions. So the question then becomes, what is obstructing that sun from shining further than the approximated 6,000 miles in all directions? What is causing that light to end? So if a photon's life is limited to just a fraction of a second, and it is reabsorbed or scattered and absorbed by an electron, it may be part of what's causing the aurora borealis in the north and in the south. So due to the magnetic fields of the Earth and maybe of the sun also, we don't know that there's a toroidal field around the sun, but it's a possibility. But when that light ends, we don't know the manner in which it ends. But it's feasible as a photon reaches the end of its life cycle, it may slow down and it may be reabsorbed by an electron, and that in turn may cause some of the lighting that we see on the underside of clouds and the color shifts that we see in clouds and in the aurora borealis. It may have some molecular transformation which causes some of these things to make brilliant light displays. One thing that we do know, that as this field of light moves away from us at sunset, that it has a gradual transformation from light to dark, and it's dome-shaped, and the sun rays seem to emanate from the sun and end at that barrier. And we also know and can observe that it appears that sun rays emanate from the sun in all directions. And the barrier that we see appears also to be the limitation on the outer reaches of those rays. We can best view this through time-lapse photography, and because it condenses it down into a nice, neat little package. And the sun being high above our plane Earth, it would be reasonable with the light rays emanating in all directions that it feasibly could reach to the other side, unless its angle is too steep and it ends. But that doesn't seem likely because of the shape of what we see in the receding field of light at sunset. Now, what I think is that the sun is high above the earth. And I could be wrong, but it just seems to me that that light, unobstructed, would shine to the extent of the surface of the earth. And if it was obstructed by anything, like, say, angle, it may vanish from the ground, but the atmosphere itself would still be illuminated, and we don't see that. But what we see is an abrupt end of that light as it passes by us, and that end moves right along with the sun, as if it was at a set, fixed distance away from the center of the sun. What I think is more likely, of course you've already heard me say this, but that the field of light is the extent of the reach of a photon that emanates out of the sun. Now we're 11 minutes into this video, so I'm just going to mention the field of the earth and the light field of the sun, and this is how I think they might look. And they do meet near the North Pole, which would be where we see a lot of the aurora borealis, but it's said that it also occurs down near Antarctica. I have quite a number of time-lapse photography of the light field passing off toward the horizon at just after sunset, and I'd like to display those for you. But first I have 2 more graphics to show, and then the rest of the video will consist of video clips showing the light field as it passes out of our perspective view. So we have here our terrestrial plane with the field of the earth and the sun making a clockwise rotation, and then the directions of the field of light and its reach out of the sun. And again, I think those are about 6,000 miles from the center. Now, when we look at this field of light, it appears to be about 12,000 miles in reality, and 6,000 from the center. This is what we know in reality from sunrise to sunset is about 12,000 miles. The question that arises is what stops it from reaching any further than that, from 6,000 from the center. Is the moon's altitude insufficient for light to reach the other side, and it dissipates about 6,000 miles away from the sun? Or is it that light itself is limited in its reach? That's the question. I can't give you the answer. All I can do is give you some observations, and then you decide. I like this verse from 2 Timothy 3:7. Men who are ever learning and never able to come to the knowledge of the truth. And that's no matter how much they learn, they're constantly learning and never able. In other words, they're never able to formulate any kind of conclusion with all the stuff they learn, no matter how much that is. So now we're going to get into some of the video examples of the light as it passes overhead and vanishes off into the horizon. And watch the pattern this makes, kind of an oval, domed shape, as it dissipates and moves out of sight. Yeah, I'd like to get anybody's comments or suggestions on what they think is actually happening on a flat terrestrial plane perspective, and that'd be interesting to put all of our heads together and decide what is the most probable and practical conclusion to what we're witnessing. In some of these, it's not real evident when I put the drawing on the screen capture, but this is kind of where the line appeared to be to me. It got a little bit lower there. This is a nice little video. The guy did a time-lapse overnight, and this is the sunset, and then he swings around all the way to the sunrise. Kind of cool. Took a lot of work. Yeah, I'm not going to add any music to these because every time I do, I get kicked off of YouTube or wherever. I just don't want the problems, so I just leave it off and I don't have to worry about it. One thing about people that are doing these time-lapse, they're doing it for the sunset effect, and they cut it off and don't go until the light dissipates out of sight. And I get it. I understand why they do that. But so what do you think's actually illuminating the bottom of those clouds? Do you think it's the angle of the sun when it's far enough away? Well, we know it's quite a ways above those clouds. In this upcoming video clip, pay close attention to the lighting on the underside of the clouds and the perspective angle of the sun, and then the reality of the angle of the sun. Color is derived from light, and when the final bit of light is pulled away, you lose color because you have no light. And see, the final clouds, they dissipate, but it takes a little while for them to get to it because they're further away, quite a bit further away. Let's play it again. Here it comes. There goes the light and the color. Color comes from light. If you don't have it, you don't have no color. And there we go. What I think you just saw was the outer edges, outer reaches of the toroidal field passing by. Watch the illuminated underside of these clouds as the light barrier passes downward toward the horizon. See it going there? Yeah, and then it goes out of sight, and then it takes a while, then the other little line of clouds starts to lose its color as the edge of that field passes by. And then that field just keeps on going until everything's dark. I've got some better visuals of the field of light. I like this one. I had to slow it down quite a bit so you can see it. But you can see that field now is starting to go down, and you see a real clear, distinct barrier. And this one you can see it moving off to the right. And this one, as it comes, it's a sunrise as it's coming up, and it's hitting a barrier of clouds, but it's continuing behind it in that domed field, the barrier between the light and dark. In this next video clip, you have to watch right at the very beginning because it doesn't last very long, but you can see the domed shaped field coming in right here in just a second. right there. Now watch over to the left, and you'll see the field coming in, and it'll move across the sky to the right. There you go. Now this field preceded the actual sunrise by quite a little bit, because you see the sun coming up now here. So it was quite a ways past, out from the sun. Now watch as the upper right and upper left corners start getting darker as the field is passing by and coming down toward the horizon. And it keeps on going. Definitely the light can't shine any further than that for some reason. And it's moving right along with the sun. So it's about 6,000 miles away from the sun is all. But it's moving probably the speed of the sun. Oh yeah, this is that same one I played earlier, I think. And then see, that was during a crescent moon when the moon is still within the field of light. And perception makes it look like it's not. Now on this one, the sun had been moving all afternoon, and it's reaching our vanishing point, and that light barrier is now coming into view, and it's following the sun out of our sight. Now this is a sunset. It keeps getting brighter because it's passing through the clouds there. So watch as it comes down. You don't see the light field until the very end here, just for a moment. So you have to watch quicker now. Here it comes. There it goes. In this one, you see the light field vanishing off toward the right. It's coming down, and there it goes. This is a sunrise to the left, and you see the field coming into view. Here it comes. I think that's the limit of the light, not because there's anything obstructing it. I don't think the angle of the moon's or the sun's doing that either. And this is the San Francisco landing that I played in the beginning of the video. It's more of a complete view of it, unobstructed without me cutting it. But look at that. It's not the window causing it either. You can watch it here and you realize it's not the arch of the plane window. That's actually what he's filming. And, they may be using filters or something on some of these cameras, but a lot of them don't look like they are. There it is. I did cut it. What the hell is this that we're seeing? What is that barrier caused from? I call it the end of light. Here's the sun rays, and that's where they terminate. But why? Is that actually the light ending prematurely before millions and billions and trillions of miles? Because that's what they cram down our throat all the time, is that light travels from these stars billions and trillions of miles away. But that's not the case. And I think this is evidence that light does have an end. It's a long ways, but We can't test this in a lab. The lab is our environment, because that's the only place that's big enough to see a light from its conception and to its end. And it travels a long distance in a short period of time. This little clip here was actually, I think, filmed in real time. I sped it up just as fast as I could. It's still not real long, but it has a real good view of the arched field of light. There's about 3 minutes left on this video of these clips, so I'll just let it play out. Have a great day. In some locations on the Earth, it might be that you see this field longer than others, because this actually seems like an awful long time. But then, on the other hand, the clips that we've been watching were actual time-lapse. This one wasn't, and so it seems to be lasting longer. But like I said, I made it go as fast as I could. You just about have to view that with a time lapse. Otherwise, you're sitting there for a long time. Most of us aren't out there watching sunsets past, till the light fades out of sight. Once the sun's gone down, it's pretty much over for most of us, when we're viewing a sunset. But I'm not interested in the sunset right now. I want to know what that arch is caused from. like me to try or a suggestion, throw it my way, and I'll test it and film it for you if you want. All right. Have a good night. Good day. Bye.